In this video, we're going to take a quick look at uncertainty in apparatus and measurements. And this is just a small area of the topic, but it can be asked in your exam. It's usually just a 1 mark question, but it's important that you know how to do that because it's very easy marks if you know what you're doing. So essentially when we use apparatus to take measurements, for example, in this, very relevant to this topic, we're talking about maybe measuring out solutions. We could be talking about using a mass balance to measure out a mass of something. All apparatus will have with it a certain degree of uncertainty, and that's really to do with its accuracy as well. I've put up a picture here of some measuring cylinders, which you'll be familiar with using. And what you may never have noticed before on the pieces of apparatus, usually actually the uncertainty is written on the apparatus. So you can see the first one here is a 25mm measuring cylinder, and it has an uncertainty of plus or minus 0.5 mils. So that means these measurements that we take are accurate to within 0.5 milliliters. Quite often the uncertainty is equal to the smallest sort of breakdown of the measurement on the apparatus, and you can see this is the smallest measurement on this first measuring cylinder is 0.5 centimeters cubed or milliliters. If you look at the next one, there's 50 mils plus or minus 0.5 mils, and then this 100 milliliter one is plus or minus 1 milliliter. If we think about these first two, you can see that the uncertainty in them is the same, but if we thought about the percentage uncertainty, they would actually be different. And essentially, the bigger the volume that's measured, if the uncertainty is the same, then obviously for the bigger volume or the bigger measuring cylinder, the percentage uncertainty will be less. Let's actually work that out. So the equation for working out the percentage uncertainty is written on page 22 of your Titrations booklet. Percentage uncertainty is the uncertainty value divided by the volume or mass measured times by 100%. So really it's just a percentage of the total volume that could potentially be measured out. So if we had a look at this 25mm measurement or measuring cylinder, the percentage uncertainty, if I just write percentage U for now, would be 0.5 milliliters over 25 milliliters times by 100%. Sorry to write over the actual measuring cylinder. That works out as 2%. But if we were to do it for the 50 milliliter measuring cylinder, I'll just do it over on the other side, the percentage uncertainty would be equal to 0.5 mil, because that's the uncertainty value that we can read on the measuring cylinder, divided by 50 milliliters times by 100%. And that comes out at 1%. And that would make sense because it's measuring twice the volume but has the same uncertainty. So you can see that it is essentially more accurate. There is a lower percentage uncertainty associated with the 50 milliliter measuring cylinder compared to the 25mm measuring cylinder. The uncertainty value of a particular piece of apparatus will vary based on the apparatus, based on how accurate it is, and you will be given that uncertainty value, so it's not like you have to learn a set uncertainty value for a particular piece of apparatus. It'll also depend on the size of it, the volume that it can measure out. But another couple of things that we would be familiar with our titrations are pipettes and burettes, and you can see I've just got these pictures from the internet. Here on the left you've got a 25 milliliter pipette that has an uncertainty of plus or minus 0.03 milliliters. So again, we could work out the percentage uncertainty by doing 0.03 divided by 25 times by 100%. The Buret here, you can see it's quite small, but it's a 50 milliliter Buret with an uncertainty of plus or minus 0.1 mil. So in an exam, you'll always be given the uncertainty value, and then just simply it's a percentage calculation. So if you look at your notes on page 22, the equation is given for you there. You do need to learn that equation as such, but just remember this is simply a percentage calculation, which hopefully you're familiar enough with doing. So it's the uncertainty value divided by the volume or mass measured, depending on what piece of apparatus we're talking about, and times by 100% to express that as a percentage. One thing I will say though, is, and they should be, but check the units are the same for your uncertainty value and your volume or mass measured. So for example, if we were talking about volume, the uncertainty value would need to be in centimetres cubed and the volume would need to be in centimetres cubed. You couldn't have one in centimetres cubed and one in decimeters cubed. Otherwise you would need to convert them, a bit like the calculations that we have been doing. Or if it was mass we were talking about, they would both need to be either in grams or both need to be in kilograms in order for those units to cancel out, essentially. So just be careful of that. But all the examples that we'll meet in the next couple of pages, the units are the same, but just to be mindful of that. So when we're talking about the uncertainty in a piece of apparatus, it is always just 1 times by the uncertainty value divided by the volume or mass. We'll see that when we're taking a measurement, that can change, but we'll come back to that in a little minute. So just check that it's a piece of apparatus. So let me do the first worked example for you and with you, and then you can try worked example 2 and 3 in your own. So it says a volume of 25 centimetres cubed is measured with a measuring cylinder. So that's our piece of apparatus. So it's just 1 times by the uncertainty value. The uncertainty value is 0.5 centimetres cubed plus or minus, and the total volume of the measuring cylinder is 25 centimetres cubed. So if I'm working out the percentage uncertainty, it's simply the uncertainty value, 0.5 centimetres cubed, over our volume measured, which is 25 centimetres cubed, times by 100%. And I would just write your working out just to be sure in case you make an error on your calculator. Again, put that into your calculator and that should work out as 2%. So what I'd like you to do is make sure you write in that example, and then I'd like you to pause this video briefly and try worked example 2 and worked example 3. So pause the video, try those for yourself, write out your working out, and then play the video again to check that you've got the right answers. So hopefully you've had a go at those for yourself, and let me just go through those and check that you've got these right so that they're correct in your notes. So for the next worked example, we're measuring out a volume of 25 centimetres cubed, but this time using a pipette, which has an uncertainty of plus or minus 0.03 centimetres cubed. So you would expect this answer to be a lot lower than with the measuring cylinder in worked example 1, and that's why we use pipettes for titrations, because they're a much more accurate way of measuring out volumes. You can see the uncertainty is much less. So working out that calculation, you should have got the percentage uncertainty is 0.03 divided by 25 times by 100% is 0.12%. So you can see that percentage is much lower. For the measuring cylinder it was 2% and this is 0.12%. So this has a much lower percentage uncertainty than the measuring cylinder. Then worked example 3, you were given a measurement of a mass and that was measured using a mass balance, so that's your apparatus. The measurement of the mass is 0.120 grams and the uncertainty is 0.001 grams. So your calculation for that is 0.001 divided by 0.12 times by 100%, which comes out as 0.833%. You'll notice from your calculator that 3 was reoccurring, but you'll notice that the values given to you in the question were each to 3 decimal places, so that's why I've given my answer to 3 decimal places as well. But the one time this calculation can change is when the apparatus that you've used involves 2 measurements. So if I scroll down here to the bottom half of your notes, what we're thinking of really here is a buret. So going back to that picture of a buret that I showed you just a minute ago, let's say we were using this 50 milliliter buret with an uncertainty of plus or minus 0.1 milliliter or centimetres cubed. Say for example we were measuring out a volume and there's only part of the buret drawn here. So say for example my initial buret reading was 40.0 centimetres cubed. That's not drawn very well, but say for example that was my initial buret reading. So there would be an uncertainty of 0.1 millilitres with that initial buret reading. That's my measurement. So that measurement would have an uncertainty of 0.1 millilitres or centimetres cubed. Say for example then we did our titration and my final buret reading was, say for example, 46.5. There would also be an uncertainty of 0.1 centimetres cubed or millilitres with that reading as well. So how we work out our titer is we take the difference between the two. So how much has been used up is the difference between 46.5 and 40. So the titer is always final Buret reading minus initial Buret reading. So if what I'm saying is that there's an uncertainty of 0.1 centimetres cubed with the final Buret reading, and there's an uncertainty of 0.1 centimetres cubed with the initial Buret reading, then the total uncertainty value, so the uncertainty value, if I just abbreviate that to UV, is going to be 2 times by 0.1 centimetres cubed. Is 0.2 centimetres cubed. So essentially what I'm saying is that if we are asked to calculate the percentage uncertainty of a titer, we've got to remember that that is involving 2 measurements, and so the uncertainty is doubled essentially. And it says here in your notes, a titer is really the difference between 2 volume readings, and so depends on 2 values, each with an uncertainty value associated with them. So when we're talking about a titer, we must double the uncertainty value. Let's look at what that means for a calculation. So let's try worked example 4 here, and this is where you've got to be really careful to read the question. Here in part A, you're told that you've got a 50 centimetre cubed Buret with an uncertainty of 0.05 centimetres cubed. Calculate the percentage uncertainty of the Buret. So you're simply being asked to calculate the percentage uncertainty of the Buret, not of a titer. And with that, you could be using the Buret just to get one reading as such. So if it's just of the piece of apparatus, then it's only 1 times by the uncertainty value. So if I was working that out, it would be percentage uncertainty is equal to 0.05 centimetres cubed divided by 50 centimetres cubed times by 100%. And that comes out as 0.1%. However, part B then says this Buret was used for an acid-base titration. The titer was found to be 22.5 centimetres cubed. Calculate the percentage uncertainty of the titer. And what we've got to remember is that involves 2 measurements, the initial Buret reading and the final Buret reading. So I've just written a wee note there, which you may want to write in your notes as well, that a titer involves 2 measurements, the initial Buret reading and the final Buret reading. And that means that the titer has an uncertainty that is doubled. So how you would write this is that the percentage uncertainty is equal to 2 times the uncertainty value. We need to go back to my part A. The uncertainty value is 0.05 centimetres cubed. That's divided by your titer, and so it's always divided by the measurement that you've taken. If you look back at worked example 1, 2 and 3, it says about the actual measurement that has been taken. So this is going to be divided by 22.5 centimetres cubed. That 0.05 is also in centimetres cubed, times by 100%. And that works out as 0.44%. So you can expect that percentage uncertainty to be higher than part A because, first of all, you're doubling the uncertainty by taking 2 readings, but also you're lowering the volume. So it's the same uncertainty value, but it is over a lower volume. So the percentage is going to be greater because the volume of your titer is only 22.5. So it's not that full 50 of the Buret that we have used. So hopefully that makes sense. Maybe sort of highlight that when you're asked, and quite often they do this too, because people then forget to times the uncertainty value by 2 for a titer. So really, if you're asked for the percentage uncertainty of any piece of apparatus or the measurement from any piece of apparatus, then it will just be your uncertainty divided by the volume or mass times by 100%. But if it's of a titer, that's really the only exception. If you're asked for the percentage uncertainty of a titer, then it will be 2 times by your uncertainty value divided by the volume of your titer times by 100%. If you wanted to make a note of that at the bottom of your page, that the percentage uncertainty of a titer is 2 times the uncertainty value divided by the titer volume, so not the total volume of the Buret, times by 100%.